start on time. This will be a first. And this is the day I thought nobody would turn up because the rain's been coming sideways. Welcome to Xcake. Lovely to see a lot of people arrived. I've got two talks to you tonight, followed by the usual slagging session with the pub later on. This is Roland from Bavaria, and
significant, right?
Roland's an iOS developer, has been an iOS developer for many years because he likes pain. And we were attempting to do this talk a couple of months ago, and everything went horribly wrong. But now Roland has come to us to do it. For those of you who are writing iOS only apps, or indeed iOS apps as well as other apps, testing is always great fun. It's only really maturing in terms of the automated testing over the past couple of years. And tools are starting to appear now to make things a little bit easier, a little bit more kind of lightweight, a little bit more natural, or in some cases unnatural, I suppose. But so Roland has been using one called Calabash. For any Ruby programmers here, there is a thing called Cucumber, which is what they call a behavior-driven development domain-specific language, which is used by many Rails developers and others. And Calabash is a type of gourd, Cucumber is also a type of gourd, so there's meant to be some kind of connection between the two. And it uses a similar approach. So we're going to have Roland talking about that first, and then we're going to have Gleb talking about the art and science and the state of the art of virtual reality, 3D as it works with mobile devices. So he's going to introduce a few devices and go into details about it. It's an area I don't know much about, whereas I know more about this. That's why I talk about this. So it proves it's going to be interesting. Without further ado, then, let's take it away, Roland.
Okay, well, thank you very much for coming. It's great, even with this weather, that so many people turn up. So I hope it's worth your time what I have to show. You can interrupt me with questions. There will be a lot of trusted co-workers being able to answer. Here's the other one. So whatever comes up, I'm pretty sure there will be an answer, maybe a good one. So we want to talk about acceptance testing with Calabash. And I'm not sure if people used it already. I just want to give a brief intro that everyone is pretty much on the same page. This red light is a little disturbing. I don't know why it is here, but anyway. So what is Calabash? That's of course the first question. So it's automated acceptance testing for mobile apps. When I say automated acceptance testing, that means we are simulating a user. We are simulating touch input on a device, and you can just run through your tests and verify that they're responding in a way that you're expected it. We will go into more detail in that later on. The nice thing is it's cross-platform, so it works on iOS and Android. I don't know about Windows Phone and all the other stuff that is out there, but we are actually at Intercom, we do use it for iOS and Android, and the idea is that you can write your test specifications once and use it on both platforms. So that's the theory. I mean, there's always, of course, in reality, there's a small gap how it works, but in theory, you can reuse a lot of the stuff on both platforms, which is nice if you make changes to any tests. It's open source and free, and what's also very convenient is it's backed by a company called Xamarin. They offer a paid service that you can do testing in the cloud. We have seen that there is a very, I would say, lively community behind that. So if you have issues, you can find people who can help you. And we also saw that when iOS 8 got released, it took them a little bit, but I would say it was a matter of a month or something until they really supported iOS 8 with the testing framework, which I think is pretty good. So in other words, once iOS 8 was public, we had our tests running and we were confident that everything works. So these are the two links. I will send the presentation around later on, so you can get them. So here's the first unicorn that's internal, because I just wanted to have a quick, presentation, a quick demo about what Calabash actually is. So you see on the left-hand side, Here I start my Calabash tests, and you will see that this, you won't be able to read it, but the point is there will be the test output coming through. So I launch Calabash here, the test suite, and I just run through one test. So I have to switch to the simulator that, I have to drag it into the foreground. So all the stuff that are happening now in the app are driven by a script. So in other words, there is no manual user input. We actually run that on our integration server. So with every commit, with every push to our integration system, all these tests run, and you don't have to do anything. And you see, as long as everything is green on the output, it's fine. If it turns red, then there is a few issues. So what we try to do here, this is one of our elements of our product. So you can build this messenger into your iOS app. And here we are trying to break it. So we are sending messages. While we are sending messages, we are replying. And this is one of the tests we're doing to make sure that every code change is still fine and it doesn't break any apps. So, I mean, I'm talking about Calabash here because that's what we are using, but there's a number of them out there. So there's Frank. I think a number of people use KIF. Others as well. I think, Oshi, you did, was it 2 years ago, a presentation about Frank?
Frank, yeah.
Yeah. So I wonder, just question to the audience, who has used one of these guys already for testing?
I've used KIF in the past. I'm currently actually wrestling with Calabash right now.
Okay, well, there's more wrestling.
So,
okay, well, I hope it will be fun. So, what did you use?
We use UI automation, but it was basically we just ran it off Appian.
Right. Yeah.
This UI automation didn't work very well.
Yeah, I think a lot of people say UI automation. I mean, that's what Apple suggests, but it's based on JavaScript and it's not really well integrated. I mean, we have found that it's also an investment, we get to that later, to really get Calabash up and running. But once it's running and once you have a basic set of steps, you can really build on that. So, of course, you would wonder if it's an investment, if I have to spend time, why would I do it? I think there's two main reasons, and I stole this slide from another presentation. If you're getting close to a deadline and you're fixing tests, and you're fixing bugs, and then suddenly there is older bugs coming back, and you feel you're in this whack-a-mole situation because you're never sure if a change is affecting something else, then I think it's definitely a good idea to have tests in place. If you start too late, it's very hard to retrofit all these tests. If you start too early, it's very hard to get them running because you make a lot of changes in the app. But definitely, if you end up in a whack-a-mole situation while you're bug fixing, I think that is a sign that you should have tests. And the other one is, if you have tests in place, you can make changes with confidence. So you can make rapid changes. If your tests run, if you have a good test coverage, we come to that later, you can be confident that you didn't break anything. And that's, I think, as a developer, is always a good feeling that you say, I've changed a number of things, tests still run, I'm fine. So I think that's really worth doing. There's other testing methods, so I think we should always try to look at the entire set of options we have out there. One is unit tests, integration tests, acceptance tests. Some people also have functional tests in there. Just a small example. So if you look at unit tests, what are unit tests doing? They are testing the smallest unit of functionality, either a class or a method. In this trivial example, I just got it somewhere from the internet, we have a phone validator that is validating a phone number. So this unit test is just, you can put any phone number in there and you can say, okay, for this phone number I'm expected to be a valid phone number or an invalid one. So this unit test would give you confidence whenever you change something in the phone validator that you still have the same behavior of that class that you're expecting. Of course, I mean, this is a trivial example. In real life, you would have dependencies in your classes. And what you would do is you would have mocks and stubs in order to simulate everything outside of that class so that you still have a contained, defined test sample for everything. So that's unit test. That's the smallest step. I think that is really worth doing as a first step when you're building your apps. And then we look at integration tests, which are built on unit tests. So integration tests, they combine these methods or these tests together, these groups, and they still check, okay, is the interaction between these modules correct? So in a integration test, you would just go through your interfaces, for instance, and you would check, is it still consistent whenever I make a change? And then if you look at acceptance tests, that's what we're going to discuss in more detail tonight. So this is performing a test on the full system. So if you have a web application, you would look at your browser and you would simulate browser input. So you don't really look at what's happening down beneath the surface. You're looking at what is exposed to the user. And you're looking at whatever a user interaction changes, is there a new dialog coming up, whatever, and you're checking that all these changes are according to your requirements. And the nice thing is these tests are described in plain English, so you could have other people, meaning non-developers, business owners, or project managers, product managers, actually reviewing these tests and say, that's what we want to test, because it's all from a user point of view. It's not a technical point of view. Of course, it has to be translated. We'll see that in a minute, but it's described in plain English. So here's a quick diagram how Calabash works in iOS. It's very similar on Android, but this is the example for iOS. So if we start on the right-hand side, we have our device or simulator, so it does work on devices as well. In your app that is running on your device, you have, when you install Calabash, you have a small HTTP server that is running inside of your app. And this is talking to whatever you have on your build server or on your development machine. So you have a set of features. So this is the definition of your tests. Here, describe what you want to test. You have a client library that is really interpreting these steps, and then it's talking to that HTTP server in your app. So in other words, if you say in your test you want to tap a specific button, then it's talking to your app and it's simulating that touch event. Or you say you want to check that there is a specific view existing with a specific size or content, then it's just checking with your app and just introspecting your view hierarchy and really verifying that this is happening actually at runtime. So this is always the technical architecture. How do we install it? So it's actually very simple. I tried it with a few apps. Mileage, MyWary. If it's not a very complex app, it does work out of the box. I had one where there were a lot of build targets. It used CocoaPods. It was maybe not cleanly set up because I've done it, I don't know, but it didn't work out of the box, so you had to do some tweaks. But in theory, in many cases, it goes like this. So you check that you have a Ruby version installed on your machine, 2.0 minimum version. It works also with Aria, but you shouldn't bother. Then you install a gem called Calabash Cucumber. So that pulls all the dependencies down. Then you go into your directory where you have your Xcake project file. And then you just execute Calabash iOS setup. So what this does is it looks at the Xcake project file, it checks how many schemes do you have, and then it says, okay, which one do you want to enable for Calabash? Normally you don't use the testing one, you use just whatever you use for to build your development build. So it makes a copy of that scheme. It modifies it in a way that it adds as we have seen, the HTTP server, and in theory, that's it. So, well, it also pulls down all the Calabash code that it can work, but after this, you should already have Calabash up and running, in theory. What you should do is the next step, generate an empty Calabash directory. So this gives you a file structure where it gives you the minimum amount of steps. It shows you it gives you a small step definition that will not fail, which is nice. So at least it gives you a starting point where you can build your Calabash tests on. When you then open your Xcake project again, you will see that there's a new scheme, a new build target created with the suffix Calabash. So if you build with this target and you don't get any errors, you're fine. And then you can just run Cucumber. So that command line tool will look for your or for your features, for your descriptions of the tests you're running, and it will just execute them. So because we have done Calabash iOS generate, there is a very simple file that is executed in that case. So that's the plain steps you need to do in order to get it up and running. If all goes well, you should see in your Xcode console, you should see a line like this. So what this tells you is when you launch the app, it also launches an HTTP server that is listening now for the other side of the Calabash framework to really remote control your app, you could say. If you got that far, everything is fine, everyone happy. If you're not that far, then maybe there is one thing you could encounter if you have, I'm looking at this dialog here, if you configured Xcode in a way that you have your build folder not in the derived data location but somewhere else, you need to tell Calabash where these build files are. Because when you execute, when you say Cucumber, it looks for the binary, it looks for the output of the build process, so that it can push it to the simulator. So in other words, if you have another, here we have another setup where we say relative to the workspace, we have our build output. You need to tell that Calabash. And how you do that is you just set an environment variable, no mouse, so export app bundle path. And you just point it to the directory where you have the output of the build files. So in other words, we are running on the phone simulator, it's debug, iPhone simulator, and then whatever your app name is, -cal.app. So that's the output of your build files, and if you point Calabash to that, it should work. Any questions so far? Am I going too fast or? Okay. So let's look at, I mentioned several times that you have a script describing your test. So this is the one that gets generated when you do the generate step. It's a very simple one. The first part is, just trying to not stumble over the cable. The first part is just a description of what this test should cover. So this, you could put anything in there. That's plain English. That is more for documentation purposes, where you say, okay, this is what you want to test, and this is the expected outcome. But once you get into the scenario, then you say, okay, this is the specific scenario in the test suite you want to run. This is something that is interpreted by Calabash, and everything is translated into, for instance, into tab events. So if you read this, it says, given I'm on the welcome screen, then I swipe left, and I wait until I don't see, please swipe left, and I take a picture. So, I mean, that sounds pretty much like English to me. So what Calabash is doing, it's looking for regular expressions. It's trying to match these steps, and you have to define what does it mean when you say, I swipe left. I mean, I swipe left is already predefined by Calabash, so you don't have to do anything. But if you have to do, if you have other steps, some complex navigations in your app, you could define your own custom steps. We'll get to that in a minute. And this will be executed somewhere in the background. But this is what the user sees, and this is the plain English approach that maybe also a project manager could write or could verify that this is what you want to test. And here we have a pattern that really makes sense. And whenever we do code reviews, I get reminded by Nacho that this we should have in our tests. You could easily write given and. So given something and then a number of conditions, but it just reads nicer if you say, okay, given you're on this screen, that's the prerequisite. When I touch this button, then I expect this to happen, and I expect something else to happen. It just reads nicer when you follow that. But you're flexible in how you just structure that. So now we have seen a very simple example. Here's a few things that I think we should also keep in mind when it gets a little bit more complex. You can run your tests on different devices. So you can run it on iPhone 6, also on different iOS releases. And the way you tell Calabash is you also export a device target, and there you just say, okay, I want to run it on iPhone 5S 7 simulator. So when it launches, it will check for that device target. It will launch the appropriate simulator, And you can also put in, of course, here your device UID, and then it will just execute on that simulator, and that usually works pretty stable. The other thing very useful is if you're debugging and you have a problem in the script, so it stops because maybe there's a typo in there or it cannot proceed. Normally it terminates the app. So you cannot really investigate what the app shows right now. But if you pass in no stop equals 1, then it completes the script, but it leaves the app open. So you can have, with the script, you can inspect what's going on in the app, and you can verify, okay, maybe the view was called in a different way or it's named in a different way. So that's always very useful for debugging purposes. The other thing that's very useful is tagging. So the -t means whatever comes next, the @current. So you can add these tags to all your scenarios. And then you say, okay, right now, Cucumber, I only want to execute the current one because I'm looking at this one scenario where I have the tag current on it because that's the one I'm testing, or that's the one I'm modifying. And once you're done, finished with the test, you would just remove the tag, check it into your repository, whatever. But this is always useful if you want to say you only want to test this specific one scenario, not all the other stuff, because it could take a while to execute everything. And the other one is very helpful if you say, okay, you want to run your tests excluding a specific tag. So if you know that a specific set of scenarios are failing for whatever reason, you can still run the other tests just by excluding that all these scenarios with that specific tag, and you can run through and check if they're working. Here's another command which is very important, and we will see that in a minute. So if you say Calabash iOS console, you will get a Ruby shell that already has Calabash preloaded, and then you can do calls to your app. So you can type in commands that will be sent and evaluated at runtime. And for instance, you can start your server in background. So that would mean if you just type start test server in background, it will just launch the simulator with your app, and then your app sits there and waits for commands. So the HTTP server would be running in that instance. So what you could do then in this console, you could just enter a command called query button. And what that will do is it looks at the view hierarchy of your app, and it looks for all the buttons that are visible on screen. So in our example, it's an array, it returns 2 elements, and here you see, okay, it's 2 rounded rect buttons. Here is the dimensions. What else do you have there that is useful? Yeah, dimensions is the most important useful, and that would mean you could really see, okay, while debugging, if you want to check that there is a specific button there, you can find it out here with that command, and then you can put that into your script where you say, I want to check for the existence of that button at that specific position. So this is in order to do it incrementally and do it interactively and do some debugging. Here's a few variations of that. If you say query button index 0, then it would mean, okay, I look for all the buttons that are in the app. I take the first one, index 0, and I look at the label. So the output of that command would be the label. So you could then check, does the label have a specific, or does it exist? You could query for that and then check, does it exist in your script? So yeah, I described that. And the other one, which is very nice, you can also have a second parameter, text. So this is an Objective-C selector. I never tried it with Swift, by the way, but anyway. So this is an Objective-C selector that is executed on that object that comes back. So here we get a URL label back, then we check for text, and then it gives you a string, an output of what's actually the text of that label. So you could check in your test, okay, you could verify, does that label have a specific text that shows up? Or if you have a text view, you can also check that here. You can also simulate touch events. If you say tab bar button item index 1, tab bar button index 1. So in other words, that would that would simulate a touch on the second tab bar, and then the app does whatever it does when you tap on that tab bar. One thing to note here is if you want to, here we have an example, label second. So you could say you want to check for the existence of a tab bar that is called second. So this is actually the accessibility label. So you could just put any text in there and check for and search for the text. But keep in mind, whatever you put into the label, that's also visible to a user who has accessibility turned on in the app. So in other words, if you put some random stuff into this label, what makes sense to you might not make sense to the user. So I would use the accessibility identifier because that's not visible to the user, but you can still access that in Calabash. So you could just search for a tab bar called second, and you don't have to put some more logic behind that. Okay, we looked now at a few simple steps. There's a huge directory. If you go to the Calabash website, there's a huge list of steps that they are providing. That's the URL. So you have steps where you say you query for specific views or objects. You can check if they are existing or not. So that means if they are on screen or not. And the other one that is very interesting, you could wait for elements to exist. So in other words, maybe you tap a button, the view controller gets pushed, the next one comes up, so it might take half a second until it shows up, but you could wait for that element to exist. Or if there's a network call, you can wait until the data is rendered in your app, and then proceed with your test. So that wait step is very crucial. You can simulate keyboard events. You can scroll in your text view, in your table view, collection view. You could scroll to a specific cell. So that's already built in. You don't have to do anything. You can use that scroll call. That's part of the Ruby API that comes with Calabash. Another thing which is very nice, if you're fighting with auto layout and you realize that you should do your tests in landscape and portrait, or you should verify that if you rotate your device, is it still working properly? That's also something you can trigger in Calabash. So you can say you navigate to a specific screen and then you rotate to landscape. And then you can check, are my views lined out properly? Or if you rotate back, is it still what you expect it to be? So that's very nice for to test as well. Another very powerful feature is having backdoors. Backdoors, what it does, it's really more an advanced thing, but you can call methods in your iOS app. So I mean, you should never ship with that, these backdoor calls in your app, but you implement them on the app delegate, and then you can, for instance, you can change the status or the behavior of your app at runtime. So you can say, whatever, change a button in the app with a backdoor, and then you verify, okay, does it really happen on screen with a Calabash step? So that's very powerful as well. And you can use macros. So here's an example. Here we define what's happening if you say, given I'm logged in as a specific username. So this is the definition when you say you log into your app with a username. And this is the entire, as just an example, this is the entire sequence of steps you're doing. And so your touch profile, which means you're touching a specific button. Then you're checking for element exists logout. So in other words, is there a button existing that says logout? Because if it is, then you're logged in. Well, this is a bad example. It does sleep, so forget that. Maybe we should ignore that. But then it's calling something else. It says, okay, another step definition, fill in username. And then you provide the username that comes into that method. So that means Calabash is typing in the username into that field. And then it's touching password label. Fill in password with my password, so it's filling in a password field. Then it's touching the done button, and then you wait until you see the logout button. That means that the login process has been completed. So this is a more complex example of, that's why I wanted to show it. It uses macros in order to call other step definitions. So you can stack them nicely. You can put them into a more complex examples, just to make it, what you would have in your scenario is just I'm logged in as a specific user, and all these steps are done in the background. So you don't have to worry about, once you have that once and it's working, you only use that more abstract description of what you want to do. Does that make sense? Okay. So, tips and tricks. It's hot in here. By the way, I forgot to mention, everyone who is patient enough to suffer through, we're almost done, so the entire presentation, I have a bunch of Intercom t-shirts with me. Oh, there's even more stuff in there. Oh. So feel free, no fighting please. There might not be enough for anyone, but we'll see. So that's for later. First, we have to do the work, right? Tips and tricks. So what's possible is you can reset your app between scenarios. So if you have something, some state changes, core data, whatever you save in the app, and you want to start with a clean defined status of your app, you can reset the app whenever you start a new scenario, which is very convenient. The other one, I think I already mentioned it, you should not use sleep, because sleep says, you sleep for a second, but that might be too long, or it might not be enough. So you should always use wait, for instance, that I say, I wait to see a specific button, because what this will do is it will check for the existence of the send button. If it's not there, it will sleep, and then we check again. So there will be a loop, 5 seconds. Well, it can define a timeout. So it will, let's say it checks for 5 seconds. If there is a send button, if it happens after 1 second, it just continues with the script because it doesn't need to wait any further. If after 5 seconds it gets a timeout, it's not there, then the test fails. So this is very elegant to speed up your tests, and you can always wait for animations to be completed, or if there's a network call to be completed until something appears on the screen. So you should always have wait instead of sleeps. So in other words, you should wait before you interact with an element, because, well, if the element isn't there, you cannot interact with it, so you should wait. And you should also wait after every action, because there should be, there could be a delay in having that completed. So you will end up having wait steps, but I think it's worth the price because it really speeds up your test. You don't waste your time sleeping too long in your test. That's another one I suffered a little bit recently. I wanted to put in a specific string into a text view, which is fine. But unfortunately, in that string there was an apostrophe, or it was even a quote, I can't remember. But so it looked fine to me. It just said, put that string into that field. But I got some really weird, because I'm not really good with Ruby, but I got some really weird errors. And then I realized, of course, whenever you put in something into a string that has a delimiter, you need to escape it, because otherwise Ruby just fails in that step. So, it's very easy to spot if you know what you're doing, but it took me a while to realize because it was late. But anyway, I found it. So you should escape quotes, or at least have simple input into your text views. And here's the other thing: if you have problems, the Google groups they're using for Calabash, they are quite active. So there's a lot of posts, I would say, every day. And normally, if you search for a specific problem that you have, chances are you will find an answer there, or at least there is someone maybe with the same problem. And we had a number of issues related to iOS 8, and so we could find answers to our problems. And I think we also created pull requests, or we created issues. So there is people somewhere, I don't know where, really working on these issues and trying to help you out. So I think it's really stable, and it's really worthwhile looking at these forums. So I think we're running a little bit late. That was just a goodie step I had in there. So I found somewhere on the internet a way to compare images, which has downsides. If you run it on a different iOS version, and it might render in a different way anyway. So I leave that for. I have that in the slides you will get later on. One thing I wanted to mention is you should add your Calabash tests into your continuous integration. So in other words, if you have tests running, and on your build server, you have all the bits and pieces there. You should also execute your Calabash tests. And well, this is maybe a bad example because there's tests failing, but the nice thing is our tests run, when we run the tests for the Intercom SDK, they run for about 20 minutes. So that's quite, because we have a lot of tests and a lot of user interaction going back and forth. So you wouldn't run them every time locally on your machine, but you can run them on the server. So 20 minutes later you will get a reply if it works or if it failed, and then you can still act upon it. So that's very convenient. And the other thing is code coverage. So it does show it. You can, when you run through your tests, it's also a lot of red there. Let me just ignore it. So in other, say it?
Nothing to be embarrassed about.
No, that's fine. Okay, it's 77%. It's not bad, right? It's 78%. So in other words, if you run through your tests, you can also enable code coverage. So at the end of the test, you will see, okay, I've tested 78% of your entire code coverage, which is useful to know. In other words, and then you could look at, okay, are there maybe some third-party libraries that are not tested? Maybe it's not a big deal, so you can ignore them. But maybe there is some other code that is not covered yet by your tests, so you want to maybe add some other tests. But if you at least have that metric of the code coverage, and if you can at least check out, okay, does it go down, maybe you need to write more tests. So that's always very useful. So I want to leave you with a few links. I found a very good UIConf talk from a guy who talked about unit testing on iOS, and he also starts off with why should you do it and why is it so hard to do, and he comes to the conclusion that it's actually not that hard to do it. So I think it's definitely worth looking at that one. There's also a video. If you go to the speaker desk link, there's also a video which is from that UIConf. It's very useful. If you want to find out more about Calabash, then you go to that link. They have everything on GitHub. All their methods are described on GitHub. Same with the Android version. I think the documentation not as comprehensive, but there is a lot of documentation there. And here is also an introduction to the. I just want to mention that if you want to test in the cloud with the Xamarin stuff, there's also a lot of stuff available there. So, as a summary, automated testing, I think it's worth mentioning here. It is an investment. Yes, I don't want to deny that. So in other words, you have to put in time initially to get it working, to get your custom steps defined. But I would say once you have the basics and you understand the basics, and once you have a set of steps that work fine in your app, you can use a lot of this stuff, and you can copy paste and build more steps. So in other words, if you add a new view controller or if you add a new feature, you can draw on the existing tests, of course. So either you modify them or you create a new one based on the existing custom steps, and you don't have to reinvent the wheel every time. So in other words, the investment pays off once you have done that first step, and once you avoided a whack-a-mole situation. I think it feels good to have tests in place. So you should never, I think you should never do it without unit testing. So we have seen that as well. I mean, you can write all the tests in the world. If you only have visual tests, you might miss some stuff. So unit tests come in handy, and you still have to do manual QA because there's always some edge cases that you only find by tapping on a device and being or simulating a user, well, a physical user. So tests cannot do everything, but it's still worth doing. So cross-platform, as I mentioned at Intercom, we have Android and iOS. We test on both platforms. And the idea is that this plain English description of the scenarios work on both sides. So in other words, you define what it means. I tap on the button because the button should be there on Android and iOS. So you just need to define that maybe the tap touch gesture is a different one, but whatever you define in your scenarios for your tests should be pretty much the same. And if you integrate it with continuous integration, code coverage, I think it gives you a proper tool in order to see, do I have enough test coverage? Should I do more for specific modules? It just gives you a better insight into what you're testing. So, any questions? So you could say, of course, this is maybe overkill, or maybe that's too much. I don't know. What do you think? What is it worth doing? do you think that would be something you will try in the future with your projects?
Yeah, I think so. One thing to say as well, just from the point of view of accessibility as well, because it leverages UI accessibility. That's also a good thing to build into your apps too.
That's true, yeah.
So it's an additional benefit that it's not just purely within the testing side of things that you actually get other visual.
Yeah, that's true. So in other words, you get the accessibility for free because you just name your buttons, you provide the labels, and that is also good for users who use accessibility. Yeah.
Well, there's very few people, like web developers, who would argue against acceptance testing at this stage. So also on mobile, there's been lagging on tools.
Yeah.
I don't think there's really a philosophical reason to be against it on mobile.
I think one reason why, especially on the iOS world, is, I mean, Apple had UI automation for a while, but whenever I looked at the WWDC talks, I always got the feeling, oh yeah, we also have that thing, but okay, now maybe it's better with Xcode and 6 with their bots. I don't know, but it always feels sometimes like, I would say, like an afterthought. I think they are getting better at this, but looking at Calabash, I think it's really mature. I think it's really ready for production, and it can be helpful. Again, it's an investment, but I think it's worth doing just because it feels good if you make a change and you say, my tests are still green. That's always a good feeling.
Can it find, I know the level it's working at is kind of at a sort of a hierarchy level, but can it find glitches like iOS 8.5 comes out and there's a weird rendering issue with with an element? Can it notice those things, or is it more like, well, it's in the view hierarchy, the fact that it's half hanging off to the right of the screen isn't really something that it's aware of?
Well, it really depends how you.
So when iOS 9 comes in, are you in a better position with these tests to say, yeah, that's working okay for us?
Yeah. Well, I think
manually doing it.
I think you would be in a better position. I mean, it really depends on what you're testing. So, for instance, if you test for the existence of a view, the test will still succeed even if the view is somewhere else.
Yeah, okay.
So, but if you check for, let's say you check for a specific position of the view, then it will fail if it's somewhere else. So that would be valuable.
And do you do that? No.
Well, not always. I mean, we have a few.
You can do snapshot testing as well.
Yeah.
So you could take basically the equivalent of taking a screenshot.
Sure.
And the framework looks at the two of them and overlays them and says everything's where it's supposed to be.
Yeah. There's a very good library. I thought I put it in, but there's a very good library from Facebook actually.
Yeah.
See, you know. So here's the guy. But anyway, so this gives you a snapshot. So you have a set of where you say, whenever I do a specific action, you take a snapshot. You save that as part of a test suite. And when you run the test again, it compares against this snapshot. So if there is, the view suddenly off, the test would fail. So this is very nice. The problem we have is, we run it on a different machine and then suddenly the rendering is slightly different. So you see a few pixels are off. Or I had one example where the cursor was blinking. Sometimes the cursor is there, sometimes it's not there. And then the snapshot, of course, is different. So you say, okay, you accept, 200 pixels difference. So you would definitely catch if there's a view off. So it's worth doing. But it's never perfect. But at least, if there's, we have things where when we rotate it, suddenly it was something, the view was off. That was caught because, you rotate it back and then it was gone. So then it failed. So it is useful doing. But it's